Yeah, I remember this. I remember making a suggestion. Dividing is upside down multiplying, right? Dividing is upside down multiplying. So this is 6/7 times 1 over x, like that. Remember that step? Is that okay? Because dividing, again, is upside down multiplying. That's how they relate. So you can just make it that way. I think it'll be a little easier that way. And then if you just multiply top times top and bottom times bottom, it'll be 6 over 7x is 1/6. We good to there so far? Does everybody see what I'm doing with that thing? Okay, now, what's the easiest way to solve when you just have one fraction on each side? I mean, there's a lot of things you could do. I found it's easiest for students over the years just to cross multiply. Do you know about that? We just go diagonal, diagonal. I think we did that once or twice, didn't we? Just go diagonal, diagonal. So you see how I basically made the left side into one fraction, huh? I just made dividing upside down, multiplying, put them together, one fraction, diagonal, diagonal. So then you get 6 times 6 is 1 times 7x, like that. 36 is 7x. And then how do you get x alone? Divide by 7. And there we go. We good with that one? It's all about fractions. This unit is all about fractions. All those rules with fractions. Okay, let's do C. 9/10 minus 4/5 x. Okay. So 9/10 minus 4/5 x. Oops. Equals 5/6. Okay. Yeah. Okay. So, yeah. So, this is a hard one. So we're solving for x here. And this time it's a little different. This time there's no easy, well, I guess there is. Yeah, I guess there is. We could do what we did last time. How would we put these? Remember how last time? Let me be clear. Last time we started with two separate things, and we made the left side into one fraction, right? Because we said, well, dividing is just upside down multiply, so just multiply by the upside down and take it from there. And that was good. Could we do that here? Could we make these two fractions on the left into one, and then do the same kind of thing? How so? How do we make these two fractions? How do we subtract them? Last time it was divide. Everybody see the difference? What did I just push? There we go. Last time it was divide, so that's just multiply by the upside down. This time it's subtract. So what do you got to do when you're subtracting two fractions? Got to get the common denominator. Yeah, remember that? We got to get the common denominator. We got to make those denominators the same. So multiply top and bottom by 2. Is that good there? And so then we'll have 9/10 minus 8/10 x. The right side's just waiting, you know. So now we've made the two denominators the same, so you can put them together into one fraction. Now, here's the question that might be on your mind, and that is, it'd be good if it is, what about that x? Like, where's he going to go? Is he going to the top or the bottom or both? Or what does that x do? Do you know it's over 1, huh? Anything alone is really over 1, isn't it? It's the same as x over 1, so it goes in the top only. Does that make sense? Whenever you have something in front of a fraction multiplied, it really goes in the top. So I'll just stick that x up there in the top, and so that'll become 9 minus 8x all over 10 is 5/6. Did you track with that step then? So again, anything alone, like that x out there in the front, is really in the top, because it's really over 1, isn't it? Even though we sort of write it in the middle, kind of, really, it's in the top because it's x over 1. Like any number alone. If I just write 7, that's 7 over 1, isn't it? So you guys with me? Anything alone is really over 1, is really in the top. Okay, now what can we do? Now that we made that left side become one fraction. Each side is one fraction. What can we do now? Just diagonal, diagonal, huh? Just cross multiply, boom and boom, like that. And so 6 times 9 minus 8x is 5 times 10. Is that good? Just diagonal, diagonal, like that, cross multiply. So see how it's just like the last one? I made the left side one fraction and then went diagonal, diagonal, huh? So now, this has to distribute. 6 times 9, 54. Use your calculator if you're a little rusty on some of those times tables. 48x, 50 over there. Okay, so what do we do now to, we got to solve for x. It's like x is over here, you know, saying, and it's like this equal sign's a wall of separation, sort of. Here, in fact, let me just bring it over here. So 54 minus 48x is 50. Okay, so it's like that equal sign's a wall of separation, and the x is saying, I want to be alone. That's the goal now, right? X saying, I want to be alone. Get rid of all that stuff that's over here with me. Can I subtract these two? Would that be 54 minus... Uh-oh. Thought I knocked out my pencil. I guess it's okay. Yeah, it's good. All right. Can I just subtract those two? I think it's okay. Right. I can't because they're not like terms, huh? Right? I can't subtract those two because if that was a 54x minus 48x, then I could subtract them, huh? But he doesn't have an x. So, I did injure my pencil. It's not responding very quickly. Anyway, so what do? We got to get x alone. So, remember your algebra days? Get rid of that 54, huh? Come on, pencil. Minus 54 from both sides, like that. It's gonzo. And then that'll give us minus 48x equals, what's that? Minus 4. Last step to get x alone? Divide by that minus 48, right? Then two negatives is going to be positive. You can reduce it. What is that, 1/12? X is 1. Just divide top and bottom by 4. I just divided by 4 there, top and bottom. It's positive because the two negatives make positive. Remember all those algebra rules and fraction rules? Questions I can answer? All right. So, same kind of thing. Can you make the left side one fraction and the right side one fraction? Common denominators on both sides? So go ahead and do that. Get common denominator both sides. And make it one fraction, and then you can cross multiply. So I'll come to this guy, top and bottom by 4, right? This guy, top and bottom by 3. Like that. So that'll become 8x plus 3 over 12. The other side, top and bottom by 2 here. Top and bottom by 2. Or I guess you could just make it 6 over there, huh? You don't have to do 12. It'll work either way. Yeah, maybe I'll just make it 6. It doesn't matter. Either way it'll work. Yeah, it would be easier just to do that 3, but it'll be fine either way. So you get x minus 3 over 6. Is that okay? And then diagonal, diagonal, huh? Once you make it one fraction on each side, you can go diagonal, diagonal. If you did the 12, it's okay. That'll work too. You just have a little bigger numbers. That'll work out though. So here's the wall of separation. Distribute. 48x plus 18. Distribute. 12x minus 36. So, okay. That x is on opposite sides. So what do we do when we have x's on opposite sides? This is a little different than the last one because we only had one x last time. So here we have x's on opposite sides. Remember that from algebra? Basically, you just want to get rid of one of them. Usually the lower one. It doesn't matter. You can do either one. So like I'm just going to go minus 12x. That makes sense. You don't want two places, huh? Just get rid of one of them. It doesn't really matter which one. Just get one of them to go away like that. And then, so what do we got here? 36x plus 18. And this is minus 36. So now we got x in only one spot. See how that works? So if you have x in two spots, just get rid of one of them. Just do the opposite. What's my next step to get x alone? Yeah, get rid of the 18. Subtract 18. That's gone. And we get 36x is minus something. 50 is it 54, I think? Yeah, minus 54. Bring that over here. So 36x is minus 54. Last step is just to divide by 36. Then you can reduce that minus 54 over 36. I think, what, 9 goes into both those? Maybe even more. Well, probably 18. Anyway, I'll just take it slowly. What's that? Minus 6/4. Yeah, and then reduce it again. Would have been quicker if I did 18. So minus 3/2. When all is said and done, can you read that over there? Minus 3/2. We good? Does that make sense? Questions I can answer? All right, I'll keep moving. 15 times 3 4/5. So what should we do? We're multiplying, we're multiplying a whole number times a mixed. So what should we do about that? Any ideas? Yeah, I think that'd probably be a good idea. Just change that mixed number. Yeah, so let me just try it. When multiplying changed mixed to improper fraction. You know what I mean? Change that 3 4/5, change that mixed number to an improper fraction. Remember how that works? How do you change a mixed number to an improper?
3 over 1.
What's that?
3 over 1.
Oh, yeah, good comment. Let's talk about that. Yeah, remember how I was just saying a minute ago that any whole number is over 1. It is over 1. That's true. Yeah, here, let me, that encourages me to talk about this for a second. Now, the official rule is to multiply the bottom and add the top, huh? Right? 3 times 5 is 15. So 15, right? Add 4, which is 19 all over 5. It's going to become 19/5, right? That's changing the mixed number to an improper fraction, right? Now, what about the good comment that, hey, you just said, Mr. Heron, that 3 is 3 over 1. So what about that? How does that fit with this truth? Remember, I'm trying to make, I don't want to just tell you guys a rule because you're going to be teachers of this. I want to help you to be masters who really understand every angle about why this is true. So you know the rule, multiply the bottom, add the top. That's correct. Great rule. But why is that true? How about the comment being made, well, didn't you also say that 3 is 3 over 1? So why can't I just go 3 times 4 is 12, 5th, but that's a different answer, so something's wrong. What's wrong with that? I thought 3 was 3 over 1. Didn't I just say that? I did a couple minutes ago. So why is it not working? What am I doing wrong? Should I have gotten a common denominator? So if I multiplied top and bottom by 5, would that have helped? By 5 here, like that. So that'd be 15, whoops, pencil's not working right. 15 over 5 times 4 over 5, that'd be 60 over 25. That reduces to be the same thing. What am I doing wrong? I'm multiplying instead of adding? Good question, good comment. Yeah. Should there be, what goes in the middle? I put a times, but should it really be add? What do you think? Mixed number. Is a mixed number, what's in the middle? Should it be plus or should it be times? Plus. How do you know? What's that?
It's 3 whole and then also the 4th, so it's all one number.
Yes, I love that answer. That's the best kind of answer to give to my question, is you're being real with it. You're being real with it. Yeah, exactly. Because you know what? Somebody could say this. Think about this for a minute. A child who's been pretty well taught could say, look, I learned from my teachers, maybe my last year, whatever, a good, true fact, and that is if there's no symbol in the middle, that's supposed to be times, isn't it? But that's actually not true here with mixed numbers. Yeah, have you ever heard that, right? No symbol in the middle, times. Well, mixed numbers is kind of an exception to that rule. Now, why? How do you know? Yeah, the best answer is exactly what you're saying. You would say to that young person, you'd say, just think for a minute what 3 4/5 really means. If I said, hey, I've got 3 4/5 candy bars in my backpack. What does that mean? I have 4/5 of a candy bar 3 times? Is that what I mean by that statement? No. We all know you don't mean that. We mean I have 3 whole candy bars plus I have 4/5 of another candy bar. We know that's what 3 4/5 really means in the real world, don't we? It really means plus. So this is the one time that I know of in all of math when you have no symbol in the middle really means plus. Okay, so what am I talking through all that? Because then if you come back here, like Jose said, get a common denominator and add them, that's the right answer. 19/5 is the right answer, which is what we really got the other way. So yes, long story short to say, it is 3/1. It is 3/1. And now you see, do you see why we multiply by the bottom? See that 3 times 5 there? That's just a shortcut way to get common denominator. Does everybody see that now? Let me do it one more time. 3 4/5. What's the shortcut rule? Multiply the bottom, add the top, right? 3 times 5, 15. Add the 4. Keep the number. Why are we doing that? Because that's exactly what you would do if you added those common denominator, right? Because that's what it really means. 3/1. You would multiply top and bottom by 5. See the times 5 times the bottom? You see that? That's just to get a common number and then add the top, huh? Do you see that? That's the kind of thing that Common Core has you do more, is really give the reasons why rules are true. And that's good. That's good to really think that out. That's all it is. It's a shortcut for common denominator. Good. All right, so let's go back here. So then let's convert this. We'll multiply the bottom, add the top. So it becomes 15 times, it's going to be what? 19/5. So just convert it. Now, how do you multiply a whole? This is multiply in the middle here. They put a dot there. How do you multiply a whole number? Over 1, like we've been talking about. Now just put that over 1. So that'd be, bring it over here. 15/1 times 19/5. And how do we multiply those two fractions? What do? Cross cancel. Goes in there 3 times. And then whatever's left over, 3 times 19 was a 30, 20, 57? 57 is our answer. So anyway, that was a long explanation because I showed all kinds of side things. But all you need to do is take that mixed number, change it to improper, and then multiply, which involves cross-canceling. Good? So like 3 2/5 times 9 2/3. What is that about? Well, I don't know. What you could do is you could just round the numbers. You know what I mean? 3 and 2/5, I mean. 3 and 2/5. Does that round closer to 3 or closer to 4? Let's just round them to the nearest whole number. 3, if I said I have 3 2/5 candy bars in my backpack, is that closer to 3 candy bars or 4 candy bars? 3, because 2/5 is less than a half, isn't it? You with me? 2/5 is less than half, so it's closer to none than 1. And how about 9 2/3? Is that closer? What's that round off? What's the nearest whole number? 10. That's closer to 10, isn't it? 9 2/3 is almost 10 whole candy bars. Multiply that, 30. 30 is a good estimate. Make sense how we're doing the estimation? Let's try the next one. 4 5/12. Well, here, we'll do that here. 4 5/12. 7 and not 7 over 1/10. Oh, that one's a little more tricky. Yeah. 4 5/12 is really, really close to 4.5, isn't it? It's super close to 4.5. 7, this fraction is really small. It might as well just be 7, right? You with me on that? See what happened there? So it's really 7 times 4.5. Now you might wonder, why didn't you round that to a whole number? Well, because he's really close to 4.5. He's right in the middle. We better make him 4.5. So then you just multiply that. You can do that by hand, right? 5 times 7, 35, 28, 20, 30, 31. Decimal over 1, 31.5. What's that close to? 32. Super close to 32. Is that good? Everybody see what I did there? Okay. So say no. They don't want you to be that exact, which is nice. It makes the problem easier. So in other words, they don't want you to be so precise. Forget about that. They want you to just go back and say, look, that's 4, that's 7, it's 28. Even though I think that's kind of a bad problem myself. So that's what they want you to do. They want you to round to the nearest whole number. So I rounded too closely. Is that making sense there? They just want you to say 4. Because 5/12 is less than a half. So it rounds down to 4. This is way less than a half. So 4 times 7, 28. That's the answer they really want. Oh, no. Bless you. Let's do this one. 3 to the second times 3. So this wants you to simplify. Does anybody remember the rules of powers? Just a little brush up on the rules of powers. What's that equal? How about I give multiple choice? 9 to the 9th, 9 to the 14th, 3 to the 9th, 3 to the 14th, none of the above. That's a 14 there. Okay, you ready? Multiple choice. Let's vote as a class. Everybody got their mind made up? How many say A? Nobody likes A. How many says B? Nobody likes B. How many like C? Chunk like C. How many like D? A couple like D. None above. How many don't want to vote? All right. Yeah. Anybody give any reasons for the answer? Looks like C is it by popular demand, but it's not always the truth. Is that right? Is it C? Is C the right answer? It's one you guys like best. Why? Shouldn't we multiply 3 times 3? But isn't it say times? What's the deal? How would you explain that to a kid? He says, what? It's multiply. 3 times 3 is 9.
It's already multiplied to the powers of it.
Yeah, good. Good way to say that. Yeah. Probably I'd say that same thing. I would just say, well, what is 3 squared? Isn't that 2 3's multiplied? And what is 3 to the 7th? Isn't that 7 3's multiplied? So what do you got there? 9 3's, not 9 9's, huh? Isn't that what's true? Yeah, you guys are right. Yeah, so when you're multiplying bases with same bases with powers, you don't actually multiply the bases because that's not true. You just add the powers because that's true, isn't it? There's 9 3's, there's not 9 9's, huh? Yeah, so the action happens in the power. You just add the powers because that's what's true. Yeah, good. I hope you always come back to truth. Always come back to truth and reality. That's the best. Is that AB to the n plus n? Well, that's kind of weird. Basically, here's the rule. Let me give you the actual rule that'll help. It's if you have, what's the rule? I'll give a couple versions of the rule. Rule number 1, you can have A I'm not sure, to the x, let's do it this way, times b to the x, like 2 things to the, let's see, that's not what I wanted to do. You can have the same base to 2 different powers. That's like what we just did. And that's one of those to the x plus y, right? Same bases times powers n. That's what we just did with the 3's, right? We had 3, 2, 3, 7, 3 to the 2 plus 7. Okay, that's the first rule. Another rule is if you have 2 different bases, but both are the same power. Does everybody see the difference there? See, I changed it up. And number 1, the bases were the same. And number 2, the powers are the same. So what would that be? How do you do that one? That would be a times b to the x. Everybody see that? That power is on both of them. That power's on both of them. So, yeah. So now there's the rules, but I would encourage you to put in numbers. That's always the best thing, just to make it more and more real, and I think that'll help for kids as well. So let's, I know it will. Let's come back here. If you're looking at this, you're wondering, is that true or false? True or false? Put in some numbers. Just say, I don't know, maybe A is 2, B is 3, M is 2, and make them small. Make them small, easy numbers for yourself. So that'd be 2 squared times 3 cubed. I just made A2 and M2 and B3 and N3. So make it easy. Is that equal to, I'm wondering, question mark, is that equal to A times B, which is what? 2 times 3, to the 2 plus 3 power. Is that true? This is what? 6 to the 5th power? And this is 4 times what? 27? Just use your calculator. What's 4 times 27? 80, 28, I think it's 108. And that is not 108. That's something really big. 6 times 6 times 6, So no, that's not true. That's a false rule. They're kind of messing up the rule there. Is that good? Everybody see that? So I would just put in numbers. Everybody see what I did? I made A2 and M2, B3 and N3. And just worked out the left side, worked out the right side. Wasn't true. It's not a true rule. So I'll let you test B and C the same. It's 2 plus 3 to the negative 2. It's 5 to the negative 2. What's a negative power do? Does anybody remember that from algebra? What's a negative power do? Yeah, it flips it. Exactly. Negative powers flip things, make them fractions. I don't know if you remember that. So that'll become 1 over 5. And then the power becomes positive. In other words, 1/25. Does that make sense? So negative powers flip under 1. So negative powers flip the thing under 1. So that's what we do for that one. So now the other side, this is what? 1/4, and this is 1/9. So that's not true at all. 1/4 and 1/9 is not 1/25, not even close. So that's a no, that's a false. Okay with that? You could try it out more if you want to get a common denominator. I want to move on to the word problems. So that one's false. 2 to what power is 4? What power do you got to put up there to make that true? Yeah, it's got to be 2, doesn't it? X has got to be 2 because 2 to the 2nd power, 2 times 2 would be 4. So the answer is 2. All right, I'm going to move on to 14. 14a says 2 to the x, let's just do part A first off, is less than or equal to 64. What could x be that'll make that true? Well, I would just use my calculator. You'd have a calculator for this kind of a question. So let me get a fresh screen here. And I would just try putting in my numbers in my calculator. I would just say, I don't know, I have no idea. Let's try. How about if x is like 4? So take your calculator. That's going to be 2 times 2 times 2 times 2, which is 16. Is that less than or equal to 64? Yeah. Okay, how about 2 to the 5th? Let's just try going up the line. How about 2 to the 5th power? That'd be 2 times 2. That just means 5 of them, huh? So that's going to be 32. You could use the power button on your calculator if you want, if you don't want to multiply all these 2's out. Do you guys know the power button, the X to the Y, or the up arrow on some calculators? Glad to show you if you want to bring up your calculator after class. That's true. Let's try the next one. So 6 of them. 4, 5, 6. That'd be 64. Oh, that's the limit. After that, we're going to get higher than 64, huh? So 6 on down. X can be... What's going on with my pen here? X, well, I just keep dropping it. It's not a problem. So X can be any number. Oh, I know. Sorry, I'm going to have to write on the board for just a minute. Yeah, we're good. All right, I'm back in business here. So B. So everybody good on the answer to 14a? Let's make sure you're okay there. Right, so that was x less than, x can be anything less than or equal to 6. That power can be any number less than or equal to 6. So on 14b, it was 27 to the x less than 81. So if you make 27 to the 1 is just 27. That's less than 81. 27 to 2 is already bigger, isn't it? What is that, some big number? Whatever, it's too big. All right, too big. So x can be what? Less than or equal to 1. So just do all those with your calculator. Does that make sense? Just find the first time when a power goes over, then that's too much, and you got to be less than that. So less than or equal to the number right before. All right, 10 minutes for the word problem. So it says 5/7 of the students at the college of the dormitory is 8,000. Let me write that out real clear for you. So number 6. 5/7 of the students at this college live in the dorms. Okay? 5/7 of the students at the college live in the dorms. 8,000 students live in the dorms. Okay. 8,000 live in the dorms. And the question is, how many at the college? How many at the college? So there's what we want to answer. So, okay, how do we do that? There's all kinds of ways. There's several different ways. I want to show you a way that's going to be helpful to you as you become a teacher of the Common Core curriculum. And that is a way where you can picture and feel it. Rather than, because you might wonder, well, can't we just write a formula with X? And you could. Maybe I'll show you that as a backdrop as well. It's good to have both. But even better would be a physical way you can see what's happening. Here's my suggestion. I'm going to make a big old box thing. So I'm going to always do this for fractions. And I'm going to make the fraction they're telling me 5/7, so we can really see it. This is what I'm encouraging you to do on these problems. 5/7, because again, it's all about the feel. So how do you break up that thing 5/7? Just do the best you can. 1, 2, 3, 4, 5, 6, 7. So that's good enough. I'll just erase the rest. There we go. So there's 7 pieces. In fact, I'll write numbers in there if that's helpful. So there's 7 pieces. And 5/7 of the students live in the dorms. So what are they saying? They're saying this right here. These people are dorms, and these people over here are no dorms, huh? Getting the picture? You picturing the whole situation? The whole thing, from there to there, is the whole college. So we got the whole college broken up into 7s. 5/7 of the college lives in the dorms. The other 2/7 does not. Isn't that fitting what they're saying up there? So far, so good. So we're really seeing what they're saying. This is, I think, really valuable for young people wanting to go, on in math and sciences, to think this way real about fractions. Okay, now, what about the 8,000? Where does the 8,000 go? The 8,000 is the dorms. So it's 8,000 in the dorms. Remember, these are even sections, right? These are all even sections. 7 even sections. So if 8,000 are in the dorms, how many boxes is that? 5 boxes, right? For the dorm people. And there's 8,000. So how much is each of these boxes in? If there's 8,000 in the dorms, 5 boxes, I got to divide it. Don't it with your calculator, right? Just divide 8,000 by 5 and get, this is 1,600, I think. So that means this is 1,600, This is 1,600. This is 1,600. This is, in fact, they're all 1,600 because remember, they're all the same. So they all must be 1,600. Do you see how I came up with that? I just drew out what they're saying. 5/7 dorms. And dorms is 8,000. So I said, oh, 5 boxes for 8,000. Divide, that's 1,600 per box. Okay, now I'm ready to answer their final question. What is their final question to me? How many at the college? How do I figure out how many at the college? Yeah, the college, the whole college is the whole array. So that's just 1,600 times 7, isn't it? Did you use your calculator? It's 6, because every one of these boxes holds 1,600 students, doesn't it? Times 7 boxes total. I don't know what that is, 70, 42, 11200, right? 11,200 students at the college. Do you see how real that was? Not just formulas and moving X's around. That helped us to really see a portion, a fraction, that whole thing. Does that make sense what we did? You want to try? We got 4 minutes. Try one more of those. Like that. Draw this one. So, could we figure out what portion of the stock Talia owns? So, Rob owns 3/7. How much does Talia own? Half as much as Rob. So Talia is a half times 3/7, huh? Talia owns 3/14. That's Talia. We good there? Does that make sense? Talia must own 3/14 of the stock. Half as much as Rob. Double the denominator. So now how much do they own together? Together, how do we figure them out together? Well, they're different, huh? One of them owns 3/7 and one of them owns 3/14. Oh, I see what you mean. Yeah, because you're getting the common denominator. Yeah, totally. Yeah, exactly. We have to add them up, which requires common denominator, huh? To get what they have together, exactly. We have to multiply top and bottom, common denominator, top and bottom by 2. So that's, let me bring it over here. That's going to be 6/14 and 3/14. 9/14. That's together what they own. Is that good so far? So then, what part, the part owned by neither? What's the part owned by neither? Yeah, because if 9/14 is owned by them together, you could draw a box at this point if it's helpful. You don't have to. So what if I drew a big old box for 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So there's 14 and 1, 2, 3, 4, 5, 6, 7, 8, 9 is owned by them. Then what? 1, 2, 3, 4, 5. 14th is owned by neither, huh? Does that make sense? If 9/14 is owned by the two of them, then 5/14 is owned by neither. The rest of it. How are we doing? Is that good? Those fractions? Now, there's a couple I didn't do. I'll try to do those back in my office, and I'll put them up on YouTube. Okay, so here we have another fraction problem. The dress is on sale for $160. That's 1/5 off. That sale price is 1/5 off. What was the original price? So again, I'm going to draw a big fraction bar. Fifth. So I'm going to make a fifth. 1, 2, 3, 4, 5. So 5 even sections. And 1/5 off. So that means they took this part off, 1/5. And this right here. Let me change my color. This is the sale price right here. So the sale price, which is $160 right there. Sale price is $160, and it's 1/5 off the original. The whole thing, this whole fraction, this whole bar is the original price. Right, to get the idea, all 5 boxes are the original price. The sale price is 1/5 off, so it's just 4 boxes. And the sale price comes out to be 160, so that must be divided by 4 boxes, right? There's 1, 2, 3, 4 boxes in the sale price, is $40 per box. So each of these is $40. So this must be $40, $40, $40. They're all the same. So even this one is $40. So now we can answer their question. What was the original price? Original price is $40 times 5, $200. Okay, so here we have a pretty tricky question. John took all his savings and he spent $88, then 1/4 of the amount left on presents, then 4/11 of the amount left into a checking account, then donated the amount left, $420. How much was originally taken out of the savings? Okay, so the key to doing this problem, let me go to a fresh screen and show you, and we'll come back to this screen. The key is, it's all about these fractions. If I, let's say, have some kind of amount, call it X, and then give away, let's say, 2/5 of the amount. So say then give away 2/5 of the amount. How much remains? All right, if you have, just imagine a big fraction bar. We're not going to draw fraction bars, but just for this one. If I have, there's my whole amount. There's my amount, call it X, that's my amount. And if I give away 2/5, like boom, boom, 2/5, right? 1, 2, 3, 4, 5, give away 2/5. What remains is 3/5 of X, 3/5 of the original, 3/5 times the original. Okay, that's the idea. So let's come back over here. If John took all of his savings, first off, so let's let X, how much he has in savings, we'll call how much he has in savings originally X. That's what we're trying to figure out. So what did John do? He spent 88. So what does he have left? He spent 88. What does he have? What does he have left? I'm going to figure out how much he has left after each move. X minus 88, right? Because he had X in savings and he spent 88. So now he has left X minus 88. Then, next, he spends, I should have written spends here, spends 1/4 on presents. So how much does he have left? 3/4 of that, right? 3/4. He has 3/4 of the X minus 88 because he spent 1/4 of the remaining amount on presents. Next, then, he spends 4/11. Here, puts it into checking. 4/11. So that means he keeps, what's that going to be? 7/11. So the remaining amount here is 7/11 times 3/4 times X minus 88. So to get it, we just keep taking the last amount and multiplying by the remaining amount. So we start with x, and we subtract 88 because he spent 88. And then we take that, and he spends 1/4, so that puts a 3/4 left in front. 3/4 of the remaining amount is left. Next, he spends 4/11, so that means he keeps 7/11. So 7/11 of the remaining amount is left. And that is equal to 420, because that's what he had left in the end to donate. So we have an equation. 7/11 times 3/4 times x minus 88 equals 420. That's the final amount he had left to donate. So we need to solve that question for x. So how do we solve that question? Let's go to a fresh screen here. So 7/11 times 3/4 times x minus 88 is, what was it? 7/11 3/4 x minus 88, 420. Right, we get that right? Yeah. Okay, now we got to solve for x. How do we solve for x? We basically work our way down to x. Start by getting rid of this 7/11, multiply 11 over 7 on both sides. Cancels, cancels. We come on down. 3/4 x minus 88. Use your calculator. That'll come out, I believe it's 660. Yeah. And next, got to get rid of that 3/4. How are we going to get rid of that 3/4? We multiply both sides by 4/3. Cancel, cancel. So x minus 88. What's that going to be? 220 times 4, 880. Final step to get x alone. Add 88. X equals, I'm not sure what that is. What is that? 20 would be 968. There it is. He originally had $968 they took out of the savings account. Okay, we're doing number 10 here. Just ignore number 11. We're doing number 10. Al saves pennies. He agreed to give 5/11 of his pennies to Bev if she would give 5/11 of what she got. And basically it's on down the line. So basically we've got Al is going to give 5/11 of his pennies to Bev, and if Bev will agree to give 5/11 of her pennies to Carl, and Carl will give 5/11 of his pennies to Danny. And Danny receives 1,500. That's 1,500 pennies received. Okay, so how do we do this then? The question is, how many pennies did Al initially have? Let's call that A for Al. The amount Al originally had was A. Okay, Al, and then he gave 5/11. So the amount Bev received is 5/11 A. Let's go back here and say Al had an amount A. He gave 5/11 of those, 5/11 of his pennies, so 5/11 A is how many Bev received. And then Carl received 5/11 of Bev's pennies. So that's 5/11 of 5/11 A. Carl received 5/11 of Bev's pennies. And then, next step, Danny's going to receive 5/11, right? Another 5/11 of 5/11 of 5/11 A. And that is 1,500. So we have an equation that's equal to 1,500. That's how many were received by Danny. And basically 3 5/11 here of A, the original amount Al had, goes to Danny, and that's 1,500. So here we have 5/11, 5/11, 5/11 A equals 1,500. There's our equation. Solve that for A. How do we do it? Well, we just keep getting rid. We multiply by 11/5 on the front. Cancel, cancel. We get 5/11 times 5/11 A. The other side, what's that going to be? Use your calculator. 3,300. Then we got to get rid of another
1, so we multiply by 11/5 on both sides again. Boom, boom. So that'll bring us down to 5/11. A is, going to use my calculator here. I'm getting 7,260. And then one more step, multiply by 11/5 one more time. We'll be down to A, the amount that Al originally had, which is 15,972 marbles. There it is.